Which type of motion is performed by the hands of this clock? Rotational motion. This pendulum shows oscillatory motion. These water droplets show rectilinear motion. But look at these three again. They show another type of motion. Can you identify it? All three show periodic motion. Periodic motion is motion that is repeated at regular time interval. The second hand of this clock repeats its rotation once every minute. The water drops from this tap are falling at fixed intervals. The swing of this pendulum is repeated once every 2 seconds. The pendulum is the best example of periodic motion, so let us look at it closely. There are different varieties of pendulums, but let us use a simple pendulum in this session. A simple pendulum is made up of a rigid support, a string suspended from the support, and a small weight called a bob tied to the end of the string. When the pendulum is at rest, it is said to be in its mean position. Now, let's set this pendulum in motion. To do so, we have to drag the bob slightly away from its mean position. While dragging the bob, ensure that the string is held taut. Do not drag the bob too far away from the mean position. Now, simply release the bob. Do not push the bob to set it in motion. When the pendulum is set in motion, it oscillates between 2 points on either side of the mean position. These are known as the extreme positions. External forces, such as gravity, reduce the swing of the pendulum until it finally comes to rest. This is known as the dampening effect. Now that we have set the pendulum in motion, let us study its oscillation. When does a pendulum complete one oscillation? When it moves from A to B? Or when it moves from A to B and back to A? The pendulum completes one oscillation when it is moved from A to B and back to A. You can also consider the movement from O to B to A and back to O. How do you correctly measure the time taken for one oscillation? There is a famous story about how Galileo, when watching the swinging movement of the church chandelier, discovered a unique property of the pendulum. He noticed that though the angle of swinging of the chandelier changed, the time taken to complete one oscillation remained constant. The time taken by a pendulum to complete one oscillation is its time period. and the time period for a pendulum remains constant. Let's now see how to measure the time period of a simple pendulum. First, set the pendulum in motion and wait for it to stabilize. Now, record the time taken by the pendulum to complete 20 oscillations. We can calculate the time period of the pendulum by dividing the time taken by n oscillations by n, the number of oscillations. The time the pendulum takes for 20 oscillations is 22 seconds. The number of oscillations n is 20. The time period of this pendulum is 1.1 seconds. Curious about his discovery, Galileo rushed home to study the motion of pendulums. He first experimented with bobs of different weights, but that did not affect the pendulum's time period. Next, he increased the initial displacement of the bob. Even this did not affect the time period of the pendulum. Finally, he changed the length of the pendulum. This did affect the time period of the pendulum. After further research, he concluded, the greater the length of the pendulum, the greater the time period.